Hi College Algebra student, this video is for chapter 3.2 domain and range. So in the first video we talk about how to find domain from a formula. Now we got to find domain and range from a graph, because if you have a graph you see all the points basically, and then so if you see the points you can actually tell where your domain and range are, where all the input and what all the output. So this is an example. It's a graph that goes like there's this loop here, and then I would say there's a turn, not a loop, like turn up, turn down, and then up, and then at the two end this goes to infinity and this goes down to infinity. So what would the domain be? So and then actually for this particular one, when I say it goes down, it's it's not restricted to a particular line. Actually it specifically would go out and then you go to forever, like negative infinity. So in terms of the y value, and then for x value, though, it would still be extending out. Now on this side it stopped here, so you see a solid dot here. That means this graph doesn't go up but stop from here. So when we look at the domain, it would be all domain means all the x. So you look at the points here, it would be from this point on all the way. So you from the graph you can see that the domain would be from negative, no, this is from negative 5, including negative 5, so you do a square bracket and then go to infinity. For range, because it's start from this point, so there's no y value above this, and this is also 5. You see the y value is 5, so you would say from 5, oh well, actually it's going down, so it is from negative infinity on the y part, negative infinity, all the way to 5y stop. Right? So when you look at range, you're looking at the y value. So all these graph points actually has a point. The highest point is 5 and the lowest point is negative infinity. So that's how you do. You basically analyze your graph and look at what the x and y. So let's do two more examples. So this one, you have a open dot and then a solid dot at this point. So you can see for domain, what are all the x in this particular line is from 2 to 8, right? From 2 to 8, but from 2 it is open. Doesn't include 2, but for 8 it is closed. What about y? Y would be how you look at this graph is only spanned from here to here, right? In terms of the y value. It doesn't go down all the way, it doesn't go beyond 8. So all these points here are like that. So what you can say would be, it's the lowest number is 6. So you look at the lowest number is 6, but it includes 6. The highest number is 8, but it doesn't include 8. It's an open dot. Okay. For this one, I have a dot here and then an open here. So what about x value? So x value would be from here, right? These are the x value. Look at the x-axis from negative 3 to 2. So negative 3 is a solid dot, so negative 3, 2, is like that. So that's domain. Range would be the y. So you would say that I have a y here, and then it span all the way go down to here, because you see this is the, if you look at this point is stop at negative 5, right? So here, you can also do it like this, look at it like this, then it doesn't interfere with your stuff. So the highest number is 4. I think it included 4. Then the lowest number is negative 5, I think. Yes, because I I'll cover it so I can see the writing. Right, it is negative 5. Negative 5 here, and including that point, so it's a square bracket. So both square bracket, and this is the range. So basically you just look at the line of the x and y. The next topics for 3.2 is piecewise function, because the main reason we study domain and range, especially for domain, is there is a certain function called a piecewise function where the output actually composed of more than one formula. In this particular case, I had an example where there's 3 formula. Now, we do not use all 3 of them in each case. It seems like, oh, f of x I have to do 3 times. No. You only pick one of them to do the output. Why? Because for a function to be a function, for every x only have one answer, right? You cannot produce 3 answers. That is not a function. So how do you pick? You will look at your x value. This is the criteria. We call it the domain. So you look at x is in which domain. Where would x falls into? If x falls into here, you use formula 1. If it's a 2, you use 2. If this x input falls into here, you use 3. So basically, you look at check your input first. Don't just put in right away. Use these 3 to pick your formula. So do an example, 2 example. Example 1, f of x is x plus 1 if x is less than negative 2. So you can say, okay, negative 2 less than. If my x input is here, then I use x plus 1. And is x greater than negative 2? If it's greater than negative 2, that means this side, including negative 2, then I use negative 2x minus 3. So let's look at f of negative 3. Where is my negative 3 located? Negative 3 is here, right? It's not on here. It's on the first formula. So I would use x plus 1. Use x plus 1. So x is the input, so it would be negative 3 plus 1 equal to negative 2. What about negative 2? Negative 2 is like right at the borderline. And when it's in the borderline, it's equal to negative 2. You use the second formula, right? Use negative 2x minus 3. And I plug a negative 2 times negative 2 minus 3. 4 minus 3 equal to 1. And then I have f of negative 1. Negative 1 is on here, right? But it is not on this line. It is on here. So it's in the domain of the second one. So I use negative 2x minus 3 again. So I do negative 2, negative 1, minus 3. Because I plug in negative 1 into the formula. So be 2 minus 3, that's equal to negative 1. Lastly, f of 0. F of 0 belongs to where? Is here also. Also this second function, 2x minus 3. So negative 2 times 0 minus 3, that is equal to negative 3. The second example we want to do this piecewise function is, so you see how this piecewise function, I think it's the same. When x is less than negative 2, you use this, like that. I want to sketch it to see what it looks like. So both of them are lines, so I would see where the boundary is first, is negative 2. So I'll do a dot line here. And then I pretend I'm drawing a line on this side of x plus 1. So at negative 2, so actually I just build a table. I think the easiest way is x, y, for this one first, equal to x plus 1. I have to have like some point at negative 2 is not supposed to be on this line, but I want to know when it is really close to like negative 1.99, negative 2 point something, what would it be? Because I want to do an open circle. So negative 2 plus 1 equal to negative 1. So I have 1 point that is negative 2. It is not a point, it is the circle. Negative 2, negative 1. So do the open circle. And then I plug in, maybe I'll plug in 0, right? So 0 plus 1 is 1. Oh no, 0 is not in the domain, so I should do negative 3. Negative 3 plus 1 is negative 2. So negative 3 is negative 2. So this is the point. So it is like that. It is a line. I know it's a line. So there is an open circle here. What about negative 2x minus 3? So again, I need to do xy, negative 2. Negative 2. Oh, -2 times -2 minus 3. So it's 4 minus 3 equal to 1. And then I can do 0 here because 0 is actually here. So that is equal to -3. So I know there's a point here. And then at x is equal to -2 is actually equal to -1. Oh, it's on the same point, right? So that's how I graph it. Now, if they're not those function, what should I do? Like if it is x squared or square root x, so let's do one. So this has 3 part. When x is less than -2, so I'm going to do a dotted line here. And then I'm going to do 2, because at x is greater than 2, then you use this, right? So I can, which one? I should do from here first, from the last one. The y is 3, so it is a constant function. So at x equal to -2, solid equal to -2, I would have a function like that, just a straight line. Square root x is like those things. I know it is like that, but I only have it from there to here. So I would do, I know it, so there is nothing here, right? So there is nothing here because it's undefined. So actually I should say it's 0. Okay, so 0. And so between these two there is undefined. So so from 0 to 2 it is square root x. So square root 2 is 1 point something, so you can just do it this way. And then for greater than -2 is absolute 2. So you would do an x and a y. So at 2 and 3, so absolute of 2 is 2, absolute 3 is 3. So it should be v-shaped, but your v is here, so you would just have a solid, and then 3 is 3, so like that. So this is very funny. There's some blank here. Okay, so this is how you sketch a function. Basically, you just pretend that you divide them into different area, and then you just within that area you graph that part.